Hi guys, Mr. Lee's here doing a higher paper from 2022, paper 1, and we're on the last one, question 14, where you have circle C1 is a circle with equation x minus 7 squared plus y plus 5 squared is 100. We have to state the centre of C1 and hence or otherwise show that the point minus 2, 7 lies outside the circle C1. Okay, and we'll go on to part B in a second. But let's get part A out the way first of all. So we have circle C1 with equation x takes 7 squared plus y plus 5 squared is 100. We look at our formula sheet and we compare it with the comparable formula there. X minus a squared plus y minus b squared is r squared is the one that we use there. So a has to be 7 and b has to be minus 5 because y minus 5 gives y plus 5 squared and r squared is 100. So r is going to be 10. So the centre is AB, written like coordinates. So the centre is 7 minus 5, and it has a radius of 10. Now let's see where minus 2, 7 lies in relation to this circle here. So x is minus 2 and y is 7. So what we're going to do is we're going to substitute minus 2 and 7 through here. And if we get 100, incidentally, then minus 2, 7 lies on it. If we get an answer less than 100, it's inside the circle. More than 100 is outside. Let's see what we get. So we have minus 2 takes 7, which is minus 9 squared, which gives you 81. Plus 7 plus 5 is 12 squared, which gives you 144. 81 plus 144 is 225. 225 is way over 100, of course, so that point there lies outside the circle. So let's move on to question B, part B. Determine the values of r for which circle C1, and don't forget C1 is the one you were given there, and C2 is the circle with the centre P, which is that point there, and it has a certain radius that we have to work out. Determine the values of r for which the circles C1 and C2 have exactly 1 point of intersection. So let's just get to work on this one. So a quick recap on circle C1. It had a centre of 7 minus 5 and a radius of 10. And circle C2 has a centre of minus 2, 7 and the radius that we're going to work out. So what we're going to do here is we're going to get the distance between the two centres, C1 and C2. To get this, I just tend to get the vector between them and work out the length of it. So 7 to minus 2 is back 9, minus 5 to 7 is up 12, and to get the length of a vector, you square them, add them, and you root your final answer. So minus 9 squared is 81, 12 squared is 144, that gives you root 225. So the distance between the two centres is the root of 225, which is 15. So let's just see the two scenarios here. So there you have the circle C1, which had a radius of 10, which you can just see up at the top there. And we have circle C2. Now the first one there is if you realise that the distance between the two centres is 15, the circles will touch at one place if the radius of C2 is 5. Remember, C1 has a radius of 10, plus the 5 gives the distance between the two of them as 15. So one scenario would be if the radius of C2 was 5. The other scenario would be if C2 was a much larger circle than C1 and the circle looked like that coming that way there. So here's a diagram here of what I'm trying to illustrate there. The other scenario would be if the radius of C2 was 25. So there's C1, there's your 15 between them, there that we got a wee minute ago, and we need another radius there, and this is what's going to happen in the second scenario, where C2 has a radius of 25. It would touch C1 like that there, and that's the other way we can have them touching at one place. So the answers is the radius is 25, and the other one that I got a wee minute ago would be if the radius was 5. There we have it there.